Hello everyone, my name is Pansala Gokul and in today's video, I will be explaining my approach to sign to text conversion project. This is the flow that we are going to go through in today's video. First of all, when we talk about sign to text, we already know that there are many approaches and implementation that are present in current environment and there are many solutions present. But why do we need more solutions? It's because there is no foolproof or complete solution available which is able to solve our problem and the need of this problem. When we talk about center text conversion, it is important that we acknowledge the field that we are covering and the wide area of technology that is included here. It not only covers machine learning but covers computer science, computer vision, and artificial intelligence also. So that is the need. Now, what kind of approaches that we have taken in this project? The first approach that I had taken into consideration was a random forest model. Next was CNN model and YOLO model with version 8. At the end of this video, I will be discussing the result of each of this and what is the future goals and further requirements that we can proceed with. This project was conducted under the guidance of Nishit Kotak sir, and currently I'm pursuing my BTech in Information and Communication Technology in my third year, Random Forest. So what was the procedure of model training? First, we had done the data collection, webcam, and with the help of Python script, we had collected videos and images. Basically, I collected videos of 10 seconds, and then from its frames, I collected images. I was able to collect the American Sign Language alphabets of all 26 alphabets there are, and this collection was organized in category. So in the final database there were 26 folders containing each of the alphabet. Then we had the total the images for individual was 245, which was done for me only. The next data collection we had done was to collect 100 images per alphabet, that too on me, which led to the data size of 2600 images. Then we completed the data processing with the help of MediaPipe and library. I was able to extract landmarks from images, and the coordinates of these landmarks were normalized. As per the model training, a machine learning model of random forest was used for this pre-processed data, and for the ratio of training model, 80-20 percentage was used. Then live, we had built one application for the sign prediction, and we were basically training the model to locate the hand gesture that is present there and create a frame around the hand, and then recognize that which alphabet or sign is present there. And for the implementation part, we were able to get 97 percent of accuracy for the first, and for the second 98 accuracy was achievable and achieved. And the user interface was built on a simple GUI with the help of Python script only. We can see the result that are present here. In the result, as it is shown, this is how for each alphabet the model was able to predict. Next, we had into consideration was CNN model. For CNN model, convolutional layer, mixed pooling, flattened layer, and dense, meaning that fully connected layer were taken into consideration. For CNN, the data collection was done in three parts. The first was again on me only for all the individual alphabets, and for that the data size was, as mentioned earlier, 2600 images. And this the problem was that there was a chance of model getting overtrained on one specific individual's signs only. That is why we moved on to the next approach and took 10 students 10 different signs into consideration. For this we chose students based on their height, their figure, their physique, and their skin color. So we tried to get as diverse data set as possible. The pre-trained model got the accuracy of 97% when it was trained on only one individual. Then when we moved on to different students of ICT, the 10 students that we had taken data set collection of, we received the accuracy of 93 percentage, and the data size of this model was 6,000 images. Again, here we had taken into consideration a simple GUI which was able to get design. In this model, we had tried to take grayscale images. So all the images that we did take got converted into grayscale after the frames that were collected, and we tried to use grayscale image techniques like thresholding and Gaussian based. More details of individual layer are present on the screen. As you can see, here are the alphabet and their output that are collected here. So this is how the model was able to perform. Next, we had taken YOLO model. For YOLO model, for each alphabet, 20 images were taken into consideration, again for 10 different ICT students, and a total of 780 images were collected, and it was trained on CPU and GPU. It was in order to get that in which this model performs best. The model was perform the model was able to perform better on GPU. After that, we had collected these images. The data size got over to 780 images in total. It was done in three. Data set was divided into three portions: training, testing, and validation. Five for test, five for image validation, and 20 images for the training purpose. The accuracy that we received were more than 90%, and the results are present on the screen for confusion matrix, PR curve, and the training and validation accuracy and their loss. Yes, so that is all for the models that we had taken into consideration. Future scope and problems that are mentioned here. NRF, for the random forest classifier, the main problem was that there were 42 feature error received. For example, we cannot apply two hands because of this error. And the second problem with random forest classifier was that random forest is not initially built for classifying the images, and hence we cannot receive better and good accuracy with it, as it uh, gives us the error of specialty. The next problem with CNN is that we have fine-tuned and trained this model in different conditions, but still it requires a certain type of lighting, which is a must. But the future goal of this model can be that we apply a lighting in a way that we train the model in a way that it does not require lighting, and it can perform well without having the gray level conversion of the signs that we are doing. And YOLO model, it was performing well, but it was not able to detect each and every alphabet in the as it is shown in the confusion matrix. So next goal of YOLO model is to apply k-fold cross validation in order to get a better result and for it to detect each and every problem. So that is all for this. Thank you for joining and listening to my approach. Thank you.
Nidilet. Bye bye. Bye bye. ने बेस अरे काय वांधो नाही बाय कर नागपूर फरीથી કર પહેલેથી લખો
What do you doing?
આંગળી યસ